sir, wait a second. Why so many?
I want this. Without this, I can't do.
Then why is only this?
Some issue with my system.
It will come again and no.
Good evening, everybody. So, thank you so much for joining today's webinar. It's very a pleasure to have you all of you with us. Before we begin, let me ask you a simple question. Have you ever looked at a product and wondered how did someone design it? It could be a mobile phone, a water bottle, a bike helmet, a computer mouse, or even a simple chair. Those products look so polished and complete that we often assume that they were created in one go. But here is the interesting part. Every single one of them started as something incredibly simple. Not a 3D model, not a complicated design, just a simple sketch. And that's the magic we are going to discover today. Today's webinar is not about becoming a SolidWorks experts in 30 minutes. That's impossible. Instead, today, think of a session as a backstage pass. Imagine watching a magician perform an amazing trick. From the audience, it looks impossible. But once you step behind the curtain, you begin to understand how the trick actually works. That is exactly what we are going to do today. We are going behind the scenes of the 3D design. By the end of this webinar, I want you to look at everyday products differently. I want you to think maybe this was used using this option, or when you see a pipe, or this look like this option. So what operation would have been done? All those things we'll be discussing today. So sit back, relax, and enjoy the journey. Let's begin our adventure and discover the magic behind every 3D model. So, so what are we going to discuss today? Today we are going to see how a great product starts. So every great product starts with a simple sketch, and then which begins as an idea that goes to this that becomes a sketch, then which becomes a 3D model, then it goes to the manufacturing, and then finally into the final product. So this is the normal stage a product gets developed. So what is there in this 3D modeling? From the sketch, when it goes to a 3D model, what is going to happen? Let us see that in detail. So, what is a 3D feature? A 3D feature will include conversion from a 2D sketch to a 3D results, which will include the features, which will, and the final stage, it will include the material, it will include the shape, and it will include the modifications. Now, what are we going to discuss here? So, let us discuss now. So, as you know, we are discussing about the SolidWorks today. what is SolidWorks first? Let me first tell me about SolidWorks. So SolidWorks is a software, 3D modeling software, parametric 3D modeling software, which was developed by a company called Dassault Systems. This Dassault system is the same team who has developed softwares called CATIA. And these things, this software has influenced the world so much that SolidWorks is considered as the most simple software to do the 3D operations. Now, we are going to discuss how to convert the 2D drawing into a 3D here. So 2D drawing to 3D, it's something like 2D is like drawing in a pen on a paper, which has only a length and a width. But whereas when it comes to a 3D model, it will go to a it will get a height also. So we'll get a three dimensional work. So let's discuss each and every part or each and uh, every feature of mostly used features in the mostly used features in this 3D modeling. So the first option is known as the extrude. First is the extrude. So what is happening in extrude? Imagine imagine you are making a cake or a bread at home. You roll the first flat sheet of dough and then use a cutter to make a circle, a square, or maybe a star shape. At this stage, the dough is still flat. Now imagine that instead of staying flat, that shape suddenly starts growing upwards. It becomes thicker and thicker until it turns into solid objects. That's exactly what extrude does. It takes a flat sketch and gives it a thickness. In other words, it changes a two-dimensional drawing into a three-dimensional drawing. So if you see, for example, if you look, imagine a brick. If you look it from the front, it looks like a simple rectangle. Now if you imagine stretching that rectangle backward, you get a brick. So similarly, like a book, a mobile phone, a chocolate bar, etc., etc. All these can be created by using extrude feature. So that's why extrude is one of the most commonly used features in SolidWorks. So you can see the points on the slide. It says straight direction. That means the sketch moves only in one straight line. It also says add material. This tells us that the extrude builds the material instead of cutting it. Then we say it is closed sketch. Imagine trying to fill a bucket that has a hole in the bottom. It won't hold water. In the same way, extrude needs a fully closed shape before it can create a solid object. Once these conditions are met, SolidWorks creates a solid model in just a few seconds. It's almost like watching a flat drawing come to life. And here is something interesting. If you open almost any mechanical part designed in SolidWorks, there is a very good chance that the first feature in the history is an extrude. It acts as the foundation for the model. Everything else is usually added or modified later. So whenever you see a simple object with the same shape from one end to the other, ask yourself, could this have started with an extrude? Most of the time, the answer is yes. Now we have learned how to build a solid object by adding material. But what if we want to make holes, slots, or openings? Instead of adding material, we now need to remove it. That's where our next feature comes, that is the extruded cut. So, we have just learned how extrude helps us build a solid object by adding material. Now, we are going to see how to make a hole through it. What we have to do, we cannot add anything, we have to remove some of the material, and that exactly is what this feature does. This feature is called the extruded cut. If the extrude is the builder, then extruded cut is the sculptor. Think about a sculptor creating a beautiful statue from a large block of stone. The statue isn't created by adding more stone, it's created by carefully removing the unwanted parts. Little by little, the final shape appears. Extruded cut works in the same way. First, we create a solid model, then we draw another sketch on one of its surfaces. This sketch tells SolidWorks exactly where we want to remove the material. And once we apply the extruded cut feature, SolidWorks cuts through the model in the straight direction following the shape of the sketch. That's why you will see straight direction is shown in the machine in the slide. Now, what is the difference between extrude and extruded cut? So extrude builds, extruded cut removes. It is the straight opposite of extrude cut is the straight opposite of extrude. Now, on both of this, the thing is, it will go only in a straight line. We can either go back or forward, or top or bottom. So, what if we want to go it in another version, or another in a if you want to go it in a curved motion? That is where our next feature, later features will come. Next, so we have seen create one way of creating 3D model. We start with a sketch, move in a straight direction. That's how extrude works. Now about different type of products. Look around your home for a moment. A water bottle, a rolling pin, a candle stand, a flower vase, a pulley, a machine shaft. Do you notice there's something common about all of them? They are round. If we try to create these only using extrude, it would take a lot of extra work. There has to be an easier way, and that's where revolve comes in. Imagine using a pottery workshop. A potter places a lump of clay on a spinning wheel. As the wheel turns, the potter generally shapes the clay with his hands. What's interesting is that the potter does not sculpt the entire pot from every side. He only shapes in one side while the clay speeds spinning. Slowly, the beautiful pot takes shape. SolidWorks also works in the same way. Instead of spinning the clay, it spins the sketch. First, we draw the profile of the object, then we draw a center line called the axis of rotation, and this axis acts as the center of the pottery wheel. When we use the revolve feature, SolidWorks spins the sketch around this axis through a full 360-degree, or if you want, we can go to a lesser degrees like 90 or 270 or 359 or whatever we want. Within seconds, a complete 3D model is created. That is revolve. This is most ideal for round parts or symmetrical parts, round symmetrical parts. Next is the revolved cut. So as I told, extruded cut is the opposite of extrude. So revolved cut is the opposite of revolve. So we just learned how revolve feature helps us create round objects by spinning a sketch around an axis. Now let's imagine something. Suppose you have designed a solid pulley for a machine. It looks perfect. But then you realize something. The belt needs a groove to sit properly. Now, when you see the drawing, it's completely solid. That will be very useful because there is no space to hold anything. So what do? We don't build another object. Instead, we remove some material, and that's exactly what revolved cut is designed to do. Like a carpenter using a wooden lathe, a wooden piece is kept spinning while the cutting tool gently removes material. Little by little, grooves, curves, and hollow sections begin to appear. This is exactly what happens inside SolidWorks also. Instead of adding material by spinning the sketch, we remove material by spinning it. The process is very simple. First, we create a sketch showing the shape we want to remove. Next, we draw an axis of motion. Finally, SolidWorks rotate that sketch around the axis and removes the material. Within a few seconds, a simple solid block can become a beautifully shaped component. Next. So far, we have learned two different ways of creating a 3D model. With extrude, we moved a sketch in straight line, and with revolve, we spun a sketch around an axis. Now let's make a complete different situation. Suppose you're designing a water pipe for a building. Will that water pipe always go straight? No. It has to turn around in corners. It may go up, down, left, right before reaching its destination. So, what is common? Common is that these dummies are not perfectly straight. They all follow a path. So how do we create shapes like this in SolidWorks? The answer is sweep. Imagine you are walking through a fresh snow while carrying a flag. As you walk, the flag follows the exact path that you take. If you turn left, the flag turns left. If you climb a hill, the flag climbs with you. It never leaves your path. Sweep works in exactly the same way. Instead of a flag, we have a profile. The profile can be circle, rectangle, or any shape, any closed shape. Then we draw a path. The path is simply the route we want our shape to follow. When we use the sweep feature, SolidWorks moves the profile along that path and creates a solid model. That's why we will see two important words in the slide, profile and path. Both are needed to create a sweep. And next is a swept cut. Swept cut actually is the opposite of swept. Here what is happening? We have a solid block of material. Inside that block you want to create a curved passage, maybe for a wire, maybe for water to flow through, or maybe for air inside the machine. Can we use an extruded cut? No. Why? Because extruded cut only moves in a straight line, and these products won't have a straight line. They have curves, bends, and smooth turns. That's exactly why we use swept cut. So for example, here what we did, you can see in the image. We just select the profile and the path, and it will go cutting through that value. Next is the loft. So far we explored some amazing ways of creating 3D models. We have pushed using a sketch through extrude, we have spun it through revolve, and we have made it follow a path using sweep. But now let's imagine something like different. Suppose I used to change a circle into a square. Can you do it in one step? No. There has to be a smooth change from one shape to another. And that's exactly where loft is designed to do. What we'll do first, we will roll up into a circle. Then we shape the other end to a square. Now with the finger, you gently blend the two shapes together. Similarly, that all happens while playing with the clay. Similarly, here what happens? Instead of moving one sketch in a straight line or along a path, loft connects two or more different sketches and creates a smooth transition between them. Like, for example, a bottle. You can see the bottom is usually wide. As it goes up, it becomes narrower. The shape changes smoothly. Or a computer mouse, the front is different from the back, yet the entire body flows beautifully from one end to another. The aircraft wing, all there are you notice that there are multiple profiles. So because that's why we need loft, because we need at least 2 3 sketches. You can also see smooth transition, which is the heart of the loft feature. Its purpose is to create a smooth connection between different shapes. This also adds material between different shapes. Now let's, as you have seen the loft feature, creating beautiful shapes by smoothly connecting different sketches. Now let's imagine the opposite. Instead of building a solid object, what if we want to remove the material while the shape changes from one end to the other? That's exactly what loft cut does. Imagine you're designing an AC air enters through a round pipe, but inside the machine, that air goes through a rectangular vent. And here is a question: can we simply drill a hole all the way through? No. Can we make a rectangular hole from other one end to other? No, because the shape needs to change gradually. As the air moves through the part, that is where loft becomes the perfect solution. It creates a smooth passage that changes from one shape to another while removing material. So in loft, first we create two or more sketches with different shapes. Then SolidWorks connect them and removes the materials between them. The result is a clean, smooth cavity inside the model. The first one, we need multiple profiles here. Just like loft, this feature also needs more than one sketch. The biggest difference between loft and loft cut: loft builds and loft cut removes. You can also notice the smooth transition. That means the cut changes shape and gradually instead of making sharp or sudden changes. This feature is commonly used where air, water, or metals need to flow smoothly. That's so we have now explored the most important 3D features in SolidWorks one by one. But here is something interesting. Real products are never created just using one feature. They will be built by combining several features together. So let's pause a moment and look back at everything we learned today. When we started this webinar, we had nothing more than a simple sketch, just a few lines on the screen, nothing much. But now look at those simple sketches can become. We have learned how extrude builds a solid, extrude builds a solid by moving a sketch in a straight direction. Extrude cut removes the material in a straight direction. Then we discovered revolve, where a sketch spins around its axis. Then revolved cut, where it removes material by spinning around the same axis. We explored sweep, where the profile follows a path to create the pipes. Then we looked at swept cut, which creates curved channels and passages by removing the material. Then we learned about loft and loft cut, which allows one shape to smoothly change into another, making beautiful product and smooth internal passages. So these are different commands in SolidWorks, like a toolbox which has a hammer, a saw, screwdriver, measuring tape, etc. Each tool has different purpose. The person cannot use just one tool to create a item, but we have to use the right tool at the right time. So SolidWorks exactly the same way. Each feature has its own special job. Some features build, some remove. Some spin, some follow a path. Some connect different shapes individually. They are simple, but when they are used together, they can create almost anything you can imagine. Even the parts used in cars, aircrafts, medical equipment, and space technology all begin with the same basic ideas. That's what makes CAD so fascinating. This isn't about learning hundreds of complicated commands, it's about understanding a few powerful features and knowing when to use each one of them. Before we finish the webinar, let's take a few minutes to look back at everything we have learned when the session started. So as I told, extrude, it adds material in a straight direction and builds a model. Extruded cut removes material in a straight direction to create holes, slots, and openings. A revolve, spin your sketch 360 degrees around an axis to create round shapes. Revolved cut, spin your sketch around an axis to remove the material. Sweep, move your profile along the path to create the curve, pipes, and more. And swept cut is move your profile along the path to cut channels, slots, and passages. Loft is the blend between profiles to create smooth and complex shapes. Loft cut, it removes the material between profiles to create the smooth internal cavities. So now we have reached the end of today's webinar. Thank you for joining me and spending your valuable time learning about additive manufacturing. I truly hope this session has given you a better understanding of how this exciting technology is transforming the mechanical industry. In today's webinar, has inspired you build a career in CNC machining and manufacturing, I'm happy to let you know that enrollments for batch 7 of our 45-day CNC operator cum programming course has now started. This is a comprehensive industry-oriented training program designed to help students and professionals develop practical skills that are required in today's manufacturing sector. Seats for the upcoming batches are limited and only a few are still available. If you are interested in joining or would like to know more about the course structure, eligibility, or admission, please feel free to contact us using the details provided on the screen. I would also like to invite you to continue the learning through our free technical webinars conducted every Saturday. Every week, we explore new topics related to CNC machining, CAD or CAM, metrology, Indian drawing, manufacturing technologies, etc. And if you do enjoy today's session, please don't forget to subscribe our channel and enable notifications so you never miss an upcoming webinar. Once again, thank you for your time, your support, and your enthusiasm for learning. This is PR Sharath Nambia, Technical Trainer signing off. Until we meet again, keep learning, keep innovating, and keep building the future. Thank you and have a wonderful weekend.